Hey folks, all right, well, Lab 6, this is where we wrap these beasties up. So, for this one, it's the rest of the translation pretty much for Wanderful-to-bash. Again, basically what we didn't have covered by the end of Lab 5 was user-defined functions and function calls, and then the runtime checks for AIs running off the edge of the map or getting created off the edge of the map. So those are pretty much the things to wrap up for Lab 6. Again, we're pretty much picking up where Lab 5 left off, so you're still having all of the compile time checking taking place, all of the translation that was from Lab 5 still taking place. It's just that now we're adding the user-defined functions and the runtime checks. So let's see. In terms of the gory details, most things are still the same as Lab 5, right? All of the translation goes to standard out. All of the error messages go to standard error. Anything else that's informational that's not actually bash goes to standard error. Let's see. I think in terms of the goals, it should all be pretty straightforward. As far as the map edge checking, the two things that you're really looking at are the move commands and the create command, because those are the two places where an AI can wind up moving off the map or landing off the map. So essentially, in those two places, in whatever bash code you've got as the translation of a move command, you want to include something in there that says, okay, well, if the AI goes off the map, then I want to print an error message, and so that the bash prints an error message. And similarly, if an AI gets created outside the map bounds, then the bash that's generated for the create, at runtime should be checking the create values that are used and generating an error message if the AI is created off the map. So again, those are runtime checks, so that's bash code that would be producing the error messages at runtime. Let's see. Other than that, the one big complication is the one that I mentioned in our Zoom discussions a week or so ago, where the big complication with bash is that return values in bash, the actual return x, only handles essentially a single byte value. It's meant to return a status code. So it's returning a value between 0 and 255 as an integer, and that's it. You can't get anything more complicated than that. And so, of course, we want to be able to return strings and to return facings and to return actual integer values that might well be a lot bigger than 255. So we've got more complicated issues to deal with. And the way that's usually done in bash is to have the bash function echo or print what you want to return and have the caller capture the output that was produced by the function and parse it to figure out what it is you want to do. But of course, this means that our compiler would need to generate bash code that did the parsing, for one thing, which actually might not be too bad in this case because all of our return values are pretty straightforward. But the other complication is that our user-defined functions might also be doing prints as well as trying to return this value. And so if we try and capture what the function produces as output, we're capturing all the things that it was supposed to be printing on the screen. And so we've got this problem that we can't really use bash's return mechanism to get values back to the caller. So since we do have pretty straightforward return values that we're sending back, right? We're sending back a name or an int or a string or a direction. One of the ways that we could do this is to just implement our own really simple return value stack. So just a stack that we'll use for values that we're returning to the caller. And again, it needs to be a stack because we might wind up with these nested function calls. So just set up a simple array as your return stack. Every time a function, one of your user-defined functions, goes to return a value, just push it on top of the stack. And whenever you get back to the caller just pops the top thing off the stack and treats that as the return value. So that should be nice and straightforward, and it'll work really well any place where you've got something like, x is assigned and then some function call. So sort of this kind of scenario, that'll work beautifully. The only place where life gets a little bit more miserable is where you've got function calls embedded in an expression someplace. Because then you've got this function call that's pushing something on the stack, this function call that's pushing something on the stack, and then this addition operation that should be grabbing these things off the stack and using them before assigning it to x. So that's something that we want to deal with. Right? So, you might wind up doing something like, say, okay, when you're generating the bash translation of this expression, go through and have it, generate the function call for the left-hand side, store that value in a temporary variable, so you're generating temporary variable names, right? Generate the function call for the right-hand side, store that in a temporary variable, add those together, and then assign the result to x. Or in a case like this, you wind up going through and storing these temporary results and storing other temporary results and adding them together and returning the eventual value. But again, you've got essentially just this multi-step process, and each of those is just one of these simple cases where I'm making this function call and assigning it to a variable. I'm making this function call and assigning it to a variable. Then I'm adding the variable values together and assigning it to a variable. We've got nice straightforward scenarios. Right? Any place where we've got a function call, we've dealt with it. So that would be my recommendation. You might think up other ideas that'll work, but that's probably the one nastiest thing that you'll need to deal with in terms of the translation for Lab 6. Again, I think the runtime checking for map sizes should be pretty straightforward. Most of the function call translation should be pretty straightforward, right? You did most of the dirty work in coming up with the parsing of it. So printing out the relevant pieces to make it, turn it into bash, shouldn't be too ugly. So hopefully this one won't be too bad. And if you want to save that that ugly return stack problem for last, that makes sense too. All right, we will leave it there for now.